So let's take a look at a couple of problems involving tangent lines and curves. And the thing to remember is that whenever you encounter problems of tangent lines, you want to remember that derivatives of a function give you slopes to the tangent lines of the graph of that function. So let's look at this example. Find the equation of the tangent line to the function y equals x cubed minus 2x at the point x equals 4. So the thing is, we want the equation of this tangent line. That means we need two things. We need a point that the line goes through, and we need a slope. And the point is really easy because you're given that x is equal to 4 here. So you could just say x is equal to 4, and y is equal to 4 cubed minus 2 times 4, because y is also given to you. And that would be 4 cubed is 64 minus 8, that's 56. So the point is 4 comma 56. And the slope, remember, is given to you by the derivative. So the first thing we need to do is to find the derivative with the power rule. Y prime is bring the 3 down, lower it by 1, 3x squared, minus the derivative of 2x is 2. But the slope isn't a number, right? It's just some kind of expression. It's just a function right now. And we got to go back to the x equals 4 and say, okay, what's the slope at x equals 4? You want to plug in x equals 4 into this expression. So the slope is equal to 3 times 4 squared minus 2, or 3 times 16 minus 2, which is 48 minus 2, or 46. And now let's put all of this together. We have the point 4, 56, and the slope of m equals 46. And remember that if you have the slope and the point if you have the slope of a line and the point that the line goes through, you can just use the point slope form y minus y1 equals m times x minus x1 to find the equation of that line. And so here, let's see, x1 is the x-coordinate of the point, that's 4. So I'll erase x1 and replace that with 4. And then I'll replace y1 and replace that with 56, which is the y-coordinate of the point. And then finally, I'll erase the slope and replace that with 46, which is the derivative at that point. And this is the equation for the line, for the tangent line. If you want to, you can turn this into y equals mx plus b form, but for our purposes, this is an equation, and depending on whether or not you need to substitute things in or find a y-intercept, you may want to put in other forms. The next thing we're going to look at is this next problem. I want to find all the points on the graph of this function y equals x cubed minus 3x plus 1, where the tangent line is in fact horizontal. And remember that a horizontal tangent line means that, or a horizontal line in general means that the slope is equal to 0. And so this problem translates to finding all the points where the slope of the tangent line is equal to 0. So these are the words are, you want to find a horizontal tangent line, but in terms of algebra, you want to find when the derivative, when the slope of the tangent line is 0. So before we figure out when that's 0, we gotta find it. Let's take the derivative. Power rule says 3x squared minus 3, and the plus 1 part, that goes away because the derivative of plus 1 is 0. And so now we want to set y prime equals 0. Right, okay, so y prime equals 0 means that 3x squared minus 3 equals 0. Can divide both sides by 3. So I'll get x squared minus 1 equals 0, x squared equals 1. And this means that x is equal to plus or minus 1, because the square root of 1 can be positive or negative in this equation. And so now going back to the function y equals x cubed minus 3x plus 1, gonna write this down here. So if x is equal to 1, then y is equal to 1 cubed, which is 1, minus 3 plus 1, or minus 1. And if x is minus 1, then y is going to be minus 1 cubed is minus 1, minus 3 times minus 1 is plus 1, so that's minus 1 plus 4, or positive 3. So we actually have 2 points where this slope of the tangent line is horizontal, and we get them by essentially finding the derivative and setting it equal to 0 and solving for the x values. And remember that since we're looking for the points, we also want the y values, and you find that by plugging those x values you got back into the original y.